Okay, so what does it mean to have a smooth, continuous graph? So by smooth, we mean no sharp corners. So this is our definition, I guess, of smooth. There, I'll underline it. So you can't have something like, an absolute value where there's a V. That would be a sharp corner. So no, not smooth. You can't have something like that, like where it's going from a linear, like a line that way and then a line that way. That would be a sharp corner, and so you can't have that. These are not smooth. So what is smooth? Well, polynomial ones are smooth. Something like this. That's a smooth curve. Okay? What do we mean by continuous? Continuous means if you trace it with your pencil, you don't lift your pencil. Okay? So this is continuous. I can trace it without lifting my pen. Okay? But if I had a graph or a function that was something like this, okay, now I've got a problem because it jumps. So I'd have to, if I were trying to trace it, I'd be like going here, then I have to pick up my pen and start here and go that way. So it has a break. That means it's not continuous. You have to be able to trace the whole thing without lifting your pen, and then it's continuous. This is an example right here of a polynomial function. Polynomial functions are smooth, continuous curves, okay? They graph to be smooth, continuous curves. Okay, so that's why we love them so much. Intercepts. So if you have a polynomial function, and think about, a sub n, x to the n plus, and then all those terms, the most x-intercepts you can have is n. So if it's third degree, then you can only have, at the most, 3 x-intercepts. If it's 7th degree, if the degree is 7, then you can only have 7 x-intercepts at the most, okay? You might not have that many intercepts. You're not guaranteed to have that many, but that's the most you can have. It goes by the degree, okay? Turning points. So say you have something like this. There's a crazy function for you. How many turning points are there? 1, 2, 3, 4, 5, 6. That means this has to be at least a 7th degree or higher degree for this function. So call this g of x. The degree has to be greater than n minus 1. Oh, no. I didn't want to write it that way. Shoot. Ignore that. Strike that. In this case, the degree has to be greater than 6. Okay? It could be 7. I'm saying this completely wrong, but what I'm telling you is true. The turning points, the most you can have, so the most turning points you can have, I'll do it in the positive direction, is n minus 1. Okay? That's the most you can have. So if I have 6 turning points, I know that my degree has to be at least 7. Could be 8, could be 9, but it has to be at least 7. Because the most number of turning points you can have is n minus 1. All right, I'm afraid I just didn't explain it well enough. So let me try again. So let's say you have f of x equals 3x to the 7th. I don't want 7. That's what I get. 12. X to the 12th power. And I'm going to ask you, pretend this is on your next test or something. And I say, what's the most number of turning points you could have. You could have 11 at the most. Okay? That'd be the most number of turning points you can have. All right, I hope that helped. A little bit longer than I wanted to make it.